Hello everyone, welcome to our presentation on an innovative approach to risk parity modeling. We've developed a factor risk parity model that combines traditional risk parity concepts with factor-based strategies. For most previous studies, apply risk parity models to traditional assets, primarily suited for low-frequency trading. These models focus on balancing risk contributions across different asset classes. But now we enhance the traditional risk parity model by incorporating factor-based concepts. This is our three V's: volume, variety, and velocity. And here is our data. We use asset data like S&P 500 index, US Treasury bond futures, and so on, and also look at the factor data. There's growth factor, inflation, credit, interest, and exchange rate, and so on. As you can see, we not only focus on US markets, but we also look into foreign markets, especially in China. Here is our macro factors we use, like economic growth, real rates, inflation, credit, emerging markets, and commodity.
In this part, I will introduce you about our methodology. First is about factor risk parity model history. The mean variance optimization model and all-weather strategy, they are all asset allocation. And for the risk allocation, the traditional risk parity strategy focuses on balancing the risk allocation of assets, aiming for equal risk contributions from all asset classes within the portfolio. However, the risk parity model has some limitations. So many studies study about factor allocation. It's mainly about macro factors and star factors. In here, we just talk about macro factors. And how should we construct our macro factors? PCA is apparently a method can reduce data dimensions by capturing key direction of variance. However, the result can be unstable, and some components may lack clear economic meaning. So we can use original macroeconomic factors. However, our method calculates the method by month. So the macroeconomic factors is low frequency. So we can use some high frequency factors as proxy, as you can see in the table. And then before implementing the factor-based risk parity model, we should calculate the factor exposure matrix. We employ multiple linear regression to estimate the beta value for each factor. And combining the coefficient from all assets, we construct the factor exposure matrix, as you can see in the picture, which serves as a foundation for subsequent calculations. And how we do our factor risk parity model? First, we find a factor exposure and use it to reformulate the traditional risk parity optimization problem and solve the new optimization problem and get our portfolio. And this is the formula. For the traditional ones, it calculates the portfolio risk and marginal risk contribution MRC, total risk contribution TRC. And for the new one, we substitute the TRC by FRC, which is using the factor exposure matrix calculated before and solve the new optimization problem and get a new result. Then we can get our portfolio. This part, I'll introduce you about our code. First is about exposure matrix. And you can see in the picture asset correlation is very low, so we can do this experiment and get the factor exposure matrix. And for the traditional ones, you can see its performance also. As you can see in the picture, the traditional one performance very well. Is the pink line and its performance very stable and better than the treasury bond. And for our risk factor parity model, you can see its performance. As you can see in the picture, its performance not as good as the traditional ones, but also very stable. We may use other factors make performance better. And go back to our code. This one means that it changes the weight automatically by month, and we can change it 2, 3, or 4, and it means that we change the weight 2 months, 3 months, or 4 months. And go back to our presentation, you can see in the results is changed weight monthly. And it also always choose the treasury bond because treasury bond has a low volatility and has a better performance at a lower risk. So always choose it.
There are four main advantages of using factor risk parity model. The first is enhanced stability. By focusing on factor-level risk parity, our model potentially offers more stable returns across various market conditions, thus showcasing the low volatility in the portfolio of our model. The second part is improved diversification. The factor-based approach allows for better diversification across underlying economic drivers rather than just asset classes. The third part is adaptability. The model can be applied to both low and high-frequency trading environments, offering greater flexibility than traditional risk parity models. This is because of the factors can have high and low frequency, which is easily adaptable to the trading environment. The last part is the scalability. Our framework can support easy integration of additional assets and factor data, allowing for expansion to global markets. The next is our demo website. The demo website considers three main parts. The first part is the asset part, which shows how the asset yields over time and how the assets are allocated in the portfolio over time. The yield over time graph shows you how each individual asset, along with the portfolio of our model, yield over time. The allocation over time graph shows you how each individual asset is weighted in the portfolio. It is worth noting that this allocation over time will change automatically every month or with regard to the trading frequency of the underlying model. The second part is the exposure matrix, which shows how the assets are linearly regressed to the corresponding factor. It's similar to the allocation over time graph. The linear regression model will update it every month with regard to the trading frequency of the model. And the last part is the asset correlation matrix and the factor correlation matrix, which is just also important in the modeling. Future direction and implications. The first, we want to optimize our factors. We want to incorporate better performing factors to refine our predictions and to increase the overall returns. And the second part is the global expansion. We want to integrate data from more than one countries and markets, not just the US or in Chinese market. We want to incorporate markets in Japan, in Europe, in other countries markets. Lastly, the industry adoption. We want to partner with financial institutions for real-world implementation of our system. And here's our references.